So my name is Alan, or just Al, and I'm a Google developer expert in Angular and Google Maps. I've been working with Angular for a very long time, started back in 2011. That was before version 1.0. It was in beta back then. And what I've been doing since then is consulting and training, and my company is angulartraining.com. And I'm also a conference speaker who gets to travel and speak at conferences like this one all around the world. So today we're going to talk about server-side rendering, and in order to make things realistic, we're going to use it on a real application. So it's a small application, license plate store with a few pages, a landing page with products, a cart page with the contents of the cart, and a checkout page. So very simple app, just a few screens, but this will be enough to give you an idea of how server-side rendering works. So let's get started with the why. Why would we use server-side rendering, also known as SSR? So first, it's important to remember what happens with regular Angular, right? When we don't do server-side rendering, what happens is that our browser navigates to a URL, and that URL is going to, get the HTML from the server and then download some JavaScript, download some CSS. And then the browser has to parse all of the HTML and interpret it. And based on what's going to be in that JavaScript, there's going to be Angular code, of course, and that Angular code is going to build the DOM. The HTML DOM structure gets built from our Angular code, which displays our components. Then these components, most likely, they're going to make HTTP requests to a server to get some data and update the DOM again to display the data. And then, once all of this is done, our page is fully rendered. So this is what happens when we use a regular Angular application. Every time you display it for the first time in a browser, we go through all these steps one by one. And maybe it sounds slow the way I describe it, and that's on purpose, because it does require to do all of this, and it can be a little bit slower than what we would expect. And the reason why all of this is happening is because if you look at the index HTML of a regular Angular app, it's going to look like this, right? It's going to be mostly empty. The body of the page is just going to have this app root element for your main app component. And then you're going to have a few scripts to download the JavaScript of the application. The CSS might be inline here or included as a dependency, as a file. Doesn't matter. It's a very small index HTML, and then we really rely on the browser to download all of this and then build the application, instantiate the DOM really at runtime in the browser. So this works, of course, because many websites are built like this, and we've been using Angular this way for many, many years, but there's an impact on performance. And depending on the complexity of your application, you can have things that are pretty slow because there's a lot of code to download before the page can be displayed. And so this is an example of a screen that comes from Lighthouse. So Lighthouse is a tool that you can use in Google Chrome to run a quick performance test on your website. And I'll show you how to do that in a second. So in that test here, my performance was 85% on that website. And we're going to run it again. So I'm going to go to that website, store.angulartraining.com. I'm opening the DevTools here and navigating to Lighthouse. And from Lighthouse, I can run this report. So just checking performance here. I'm going to click Analyze Page Load, and it's very, very quick. So I let the run happen here. It's just loading the application and measuring all sorts of metrics around the application, testing different network speeds, testing different aspects to see what's the impact on the website. And we're going to have that score very, very soon. There you go. Oh, it's even worse now. I get a 72 on that website. And so you can see that this score is divided into multiple different pieces. All of these three-letter word, FCP, LCP, TBT, CLS, and they're all detailed down here. So FCP is first contentful paint, meaning the first, how long does it take before we have enough on the screen to have all of the content displayed, right? So the first paint of the screen that has everything needed to do something meaningful. So it took 1.1 second in that case. And down here, it shows us a timeline, right? Where we can see that initially the app was empty. There was nothing going on. And then it's still empty. And then it displays loading. And then we have one component displayed and then more components. And then more data gets displayed and images and such. So we can see that it's really progressive. It takes time to load all of this from a browser perspective. And so we get a score here that's not ideal. So how do we improve that? We improve that with server-side rendering, of course. That's the topic of our talk for today. And so that's a timeline that we just talked about. The main problem with that timeline and having empty screens and then things being displayed one by one is that the layout of the website is changing, right? We're adding divs and blocks of information one after the other, which makes the layout shift around, and this has an impact on slower device. So if you have a slow computer or a tablet or a phone, on these devices, the layout shift has a bigger impact because the screen is smaller, of course, and there's usually less power in these devices as well. So if your website keeps shifting around when you load the website, then it's just gonna drain the battery. It's not a great user experience. It's slower and it requires more computing power. So that's why it's very important. Not shifting things around so much is very important. So when we do server-side rendering, the main difference of what happens is that all of the HTML is pre-generated on the server side. And because it's all pre-generated on the server side, when we access the application, we download the HTML and the CSS as we did before, but then the page is fully rendered. And that's the main difference because everything was already pre-rendered on the server. So we download everything and we have the screen displayed instantly. So it's not going to load the components one by one. Instead, we have the full page displayed right away. And then the browser starts downloading JavaScript, parse the JavaScript and interpret it. And then Angular is going to take over the DOM and control future updates. This is the process that we call hydration in server-side rendering. So when you hear the word hydration, it really means that Angular is going to use the DOM that was the HTML that was pre-generated on the server and just take over that DOM and add its event listeners and all of the code of our components to just reuse it. So it doesn't recreate the DOM from scratch. It's non-destructive hydration since Angular 17. And yeah, that's a process of really Angular loading after the fact and then taking over that DOM. So server-side rendering, as you can guess, has many benefits. Because the application and the web pages are pre-rendered on the server side, it enables caching, right? Your server can cache that information, the browser can cache the HTML, and so when a user comes back to the website, it's much faster to display it and then to reload it later because that HTML is already downloaded on the client side. Search engine optimization is of course a big deal with modern web applications. And if that's a concern of yours, then SEO usually works better with pre-rendered pages because they load faster, right? And all of these scores that we saw earlier with Lighthouse, they tend to be much better when we do server-side rendering. And so better performance, which is pretty much a summary of everything we say so far. All of the scores are going to be improved. FCP, LCP, CLS, the content of the page remains stable. You have everything loaded from the start. And as a result, the Lighthouse score is improved. So how do you enable server-side rendering? The great news is that it's been improved a lot over the last few versions of Angular, and now it is really easy to enable server-side rendering in your apps. For instance, if your project is already on v17 or v18, all you have to do is ng-add @angular/ssr. You run that command and you're good to go. Your project becomes server-side rendering compatible, and you don't have to change anything else. The schematic here is going to change your project structure automatically to add support for server-side rendering, and it's going to be enabled by default. If you want to try on a brand new project, so a brand new v17 plus project, you can just do ng-new-ssr, and it's going to do something similar, create a brand new project with the SSR structure in place. So what's the difference between an SSR project and a regular Angular project? This is the output in the terminal of the schematic when you run this command to add server-side rendering. So you can see that 3 new files are created: a main server.ts, a serverconfig.ts, and a server.ts. So 3 server-side files are created. Angular JSON is updated, of course, the TypeScript config, package JSON, because there's more dependencies, and the app config. So I'll show you what this looks like. In package JSON, we get an extra command that's added to serve the project with server-side rendering on. So that's one change. And of course, the Angular SSR package is added. So these are the 2 things that change in package JSON. There's the server-side code, which is automatically generated. So you don't have to worry about it. It's all done for you. It's using Express, and it has all of that Node.js code generated, and then nothing to worry about. Main server TS, which bootstraps the Angular application on the server side. And yeah, that's pretty much it. That's all of the changes that happen. And so then when you run ng-serve or ng-build, the project is going to be built with that server-side rendering in place. It's also important to note that hydration gets enabled automatically. So in the app config, there's this provide client hydration option that gets added. And so as a reminder, hydration is how Angular takes over the server generated HTML. So instead of recreating everything, it just takes over that HTML and basically plugs the component into that HTML structure. And it all happens in the background. We don't have to worry about it. It's all done for us. So if we compare the before and after of SSR, things usually look like this. So on my license plate store application, before using SSR, we saw that first we have a blank screen, and then things get loaded little by little, and then the app gets fully loaded, and we have a performance score that's what it is. And once we start using SSR, we get the entire page loaded right from the start, because all of the HTML is there. And so the only thing that changes is the images, right? The only difference between screen 1 and screen 2 down here is the images being loaded. but you can tell just from that timeline that the process appears to be a lot faster. And with Lighthouse, I tend to get a 100% performance score when I do that, because of course, there's no more layout shift. The first contentful paint is immediate as well, so things are a lot faster. We can take a look at that. So here I have my server-side rendered application on localhost. I'm going to go to Lighthouse. I'm going to run that test again and see what the result is. So Lighthouse always takes a few seconds. It's loading the app in different ways, with JavaScript, without JavaScript, testing different options, and my score is not that great here. So that's what happens when you test things live, because it depends on my internet connection. Sometimes it's better, sometimes it's not, but this content layout shift is improved. So the score is improved compared to before, and the CLS is now perfect. It's all green, which is really nice, because of course there's no more layout shifts at that point. So that's a good example of server-side rendering. We see that the application loads faster, the timeline is improved, and the content layout shift is gone, pretty much, which always improves the performance score. So the difference that happens when we use server-side rendering is visible in what gets built by our project. So if you look at the dist folder in your project after building the application, you'll see that there's pre-rendered HTML for all routes in the application. And I'll show that to you right away. So in my small app, I have the following config. So these are my files, src app routes. So this application has 3 routes: store view, cart view, checkout view. And so when you look at the dist folder in the browser folder, we have a cart index.html, checkout index.html, and the main index.html for the default path. And when I click on any of these, we see that what we have in here is a pre-rendered page where all of the HTML was pre-generated at compile time. So if I open the cart index.html, same thing, we have the code, we have some HTML displayed in here. It's not just the components now where there's really everything. And all of that was pre-generated at build time and then refreshed at runtime on the server side. So we get all of these static index HTMLs that are pre-generated, which didn't happen before SSR. Another thing that's happening, and that's pretty interesting to look at, I'm going to show that to you as well in the browser, is that the data for each page also gets downloaded. Because what happens is that when the server pre-renders the application, it's going to make the HTTP request from the HTTP client, if you have any. And to make the client side take over even faster, to make the hydration process even faster, that data from the server is actually cached and sent along with the HTML. So here you can see this ng state script element, and what this is, it's a JSON syntax that's the list of the products on that page, because this list of products is loaded from an HTTP request. It's an AJAX request made by the HTTP client. So the server is sending that data along with the HTML, so that when Angular takes over on the client side, for the first request, instead of trying to go to the server, it's just going to use that JSON that we already have on the client side, which makes things even faster. So it's really smart and powerful, right? There's a lot of very good ideas like this implemented in Angular server-side rendering. So now that we saw how easy it is to add server-side rendering, are there any things that we have to do differently when we use it? Are there any, downsides or exceptions to make? So for the most part, the code can remain exactly the same, meaning there's no adjustments to make, except if you're using code that is browser specific. For instance, if your JavaScript is referring to objects such as window, document, navigator, or location, of course, these are browser specific. They run on the client side, so they won't be available on the server, which means for these specific scenarios, we have a solution, and that solution comes through the form of two new lifecycle hooks that were introduced for the first time in Angular 16.2. And these hooks are called after render and after next render. So this is what they look like. You would use them in the constructor of your components. And so after render is going to run after every render on the client side only. And that's why these hooks are important. They don't run on the server side. The server side is going to do nothing with after render and after next render. It's going to ignore that. It's only going to render on the client side in the browser. So that's why you can manipulate document, navigator, all of these JavaScript client side objects and methods and properties. You can now play with them in those hooks. So the main difference between after render and after next render is that after render is going to run after every single render. So the app renders your component. If a change happens and the component re-renders, change detection and such, then this is going to run again. Whereas if you use after next render, it only runs once. So kind of like an ng on init, if you will, it's going to happen only once. So most of the time, I guess after next render is what's going to be useful. So we talked about server-side rendering, but I want to touch on static site generation as well, or known as SSG. Because the thing with server-side rendering is that we need a Node.js server, right? We need a JavaScript backend that runs that code on the server. And that can be a constraint. I know that some companies don't like that. They don't want to run Node.js on the server. They don't have the infrastructure for it. And maybe they don't want to use a cloud service for that either. So if you don't want to do that, then you can just use pre-rendering, or also known as static site generation, or SSG. And the main difference between SSG and SSR is that you just rely on the pages that are built at compile time when we run ng-build, not on the fly at runtime. So that's a very good compromise, right? Because you don't need a new server infrastructure. You can rely on what you're doing right now, and you still get a boost in terms of performance and SEO, because these pages are going to load faster since they have been pre-rendered at compile time. So it's pretty good for static content that doesn't get updated very often, or would require a build to be updated anyways. And so all you have to do in that case, if you want to use SSG, is run ng-build, which compiles your code, and then you can serve the static files from that build, just like a regular client-side Angular app. So it doesn't change a thing from how you're going to deploy that code, because as we saw earlier, it's all there, right? All of the index HTMLs have been pre-rendered already, so I can just serve that folder, and there we go. I'm compatible, and I have a statically rendered application that Angular is going to take over and refresh instantly. Another thing that's important to know about is that, when we use Angular, we use a router, and the router, by default, when you use server-side rendering or SSG, Angular is going to look at your router config and pre-render everything from there. But there are routes that have parameters, right? And Angular cannot guess what these routes are because they have parameters, such as product/1, product/523. So any route that has an ID in them, Angular would not be able to guess what these IDs are and pre-render them. So what happens is that we can help Angular with this. We can pass a routes file as a parameter, and that routes file is just a list of all of the routes to pre-render. So one by line, and you can have as many lines as you want. So if you want to pre-render, let's say you have a store and you want to pre-render all of the most common products that people are likely to buy, you can do that and list /product/1/product/2 and have all of these common URLs pre-rendered. So these two options are passed to the SSR config. Discover routes by default is true, so it's going to figure out automatically what things to re-render. You can make it false if you want to completely take this over and do it manually. And then you have the routes file option, which is where you give the path to that file and you list all of the things you want to pre-render one by one. So that's where the config is. It's in Angular JSON pre-render option. So in this example, I set discover routes to false. I pass a routes file, route to pre-render.txt. And in that file, I just say render the default page and render the cart page, but don't pre-render checkout because checkout maybe doesn't make sense to pre-render. And so yeah, that's everything I wanted to cover in this talk on server-side rendering. So thanks a lot for attending. I wanted to mention that we also have an Angular certification program that you might be interested in. So that's something I created with a couple of other GDs, and it's been running since 2020 now for 5 consecutive years, and we have thousands of people certified all around the world. So if you're interested, if you want to take a look, just head to certificates.dev/Angular. We have self-training sessions, we have boot camps that you can attend as well, and we have different levels of certification. So from junior to expert, there's really a certification for everyone to showcase your competence in Angular. And so we also have a Frontend Nation event happening in June. So that's another free online conference that's going to be multi-framework this time. So if you want to learn more about React, Vue, Angular, JavaScript, TypeScript, it's going to be multiple different tracks, 3 days. It's also free to attend online. So you can register now at frontendnation.com. And finally, if you want to follow more of my content, there's a blog.angulartraining.com where you can see my blog posts and subscribe to my free weekly Angular newsletter. And finally, I listed the link to these slides here on this final slide at bit.ly/ATSSR workshop. So thanks everyone for attending, and I hope to see you next time at Frontend Nation.